Hi everybody, today we're looking at Unit 2, Lesson 2, midpoint of a line segment. So we're going to be looking at how do we actually find the midpoint of a line on a graph, and kind of how does that come again from our rise and our run. So in the previous day's lesson, we looked at how slope helped us find the length or the distance of a line segment. We're going to talk about today how slope can also help us find the midpoint of a line segment. So if we were going to look at this line segment AB, it says label the midpoint M on the line segment AB. So if we had to guess kind of where's the middle of A and B, we could kind of work our way in and maybe see it's maybe somewhere like here. Looks like we're roughly 3 squares from B and roughly 3 squares away from A. So this is a guess. I'm not saying that that is the midpoint. But let's take a look at our rise and our run and see how that might help us solidify that that is in fact the midpoint. So if I look at A and I assessed what the run is, okay, I can come here and it looks like my run is 1, 2, 3, 4. So our run equals 4. And our rise, okay, so the distance from here to here, that's our rise. Looks like that is equal to 1, 2, 3, 4, 5, 6. Okay, so if we took a look at where's the middle of my run, okay, here's the middle of my run because we can easily see that if a line segment is 4 square units, 1, 2, 3, 4, then the midpoint is going to be 2 of those square units. Where's the midpoint of my rise? Well, again, if we know that this is 6, then 1, 2, 3 is going to be the midpoint of my rise. So if I follow those points straight up to line segment AB, I can see where are they going to intersect on AB. And they're going to intersect right where we kind of had predicted our midpoint to be. All right, so we can see that, again, by using our rise and run, it will help us determine also the midpoint of our line. So how do we determine where the midpoint should be? So in this case, we're going to use our rise and our run. So using the rise and run values between points A and B, okay, between the points, and in this case our points were A and B, the midpoint is half the rise and half the run. Okay, so how can we determine the coordinates of the midpoint if we didn't have a graph? So say we were just given 2 points and we wanted to determine the midpoint of those 2 points. What did we really do with our rise and our run if we think about what is rise and run in terms of an equation, right? So in this case, our point A was at 2, 2. So let's take that we have point A and that was at 2, 2. And we have point B and that is at 6, 8. All right. So once we had those points on our graph, if we now think algebraically, could we determine our rise and our run without a graph? Can we determine them algebraically? So let's find our rise and our run. Okay, so our rise, remember our rise is the difference between our y values. So it's our y2 minus our y1. So it would be 8 minus 2, which is equal to 6. So that is what our rise would be in this case. Let's see, our run is the difference in our x values. So our x2 minus x1, which is 6 minus 2, which will be 4. Okay, and we can see that that's what we got for our rise and our run when we look back at our graph. So whether we calculate it or we look at it on the graph, we can see we find those points either way. So for the midpoint, let's just bring that up here. So for the midpoint, we're going to divide our rise and our run. in half. Okay, and then once we divide them in half, we're going to add them to whatever our first point was. We're going to add them to point A. So we're going to divide rise and run in half, and then add them to point A. Remember, point A was 2, 2, right? Okay, so half of our run, so let's see, we'll do our rise first since that's what we started with. Oh no, I'm going to do my run because I want it to be right next to it. So our run is our x values. And I'm just going to, let's do that in another color to break it up. Okay. So our run is our x values. If we divide our run of 4 divided by 2, we're going to get 2. Okay? If we take our rise, which was our y values, okay, and we found our rise to be 6, and we divide that by 2, we're going to get 3. So we can then add to A. So my A was 2, 2. So to my run, I'm going to add 2. And to my rise, to my y, I'm going to add my rise of 3. Okay, so that's going to equal my midpoint. So 2 plus 2 is 4, and 2 plus 3 is 5. Okay, if we take a look at what do we get for our midpoint on our graph, we can see that that m is at 1, 2, 3, 4, and up 1, 2, 3, 4, 5. So our midpoint is in fact at 4, 5. So by finding the halfway point of our run, the halfway point of our rise, and then adding them to the first point on my line segment, I can figure out what's my midpoint going to be. But how can we say that in a formula without all of those kind of steps one at a time that seem a bit disjointed and not connected? What are we essentially doing, right? If we're splitting the run in half, we're really finding the average of our x values across our run, and we're finding the average of our y values across our y. So if we were to come up with a formula, we're going to put our formula in this box, just like we did for the distance formula. What we're doing is you are finding the average x and y values. So remember, when we're finding the average, we're essentially adding a list of numbers together and then dividing by how many numbers there are. So we're going to use a capital M for midpoint, not to be confused with slope, which is a lowercase m. Okay, so midpoint is going to equal, well, when I was finding the average of my run, I was basically taking my x1 plus my x2 and then dividing by 2, right? That's taking the average of those two values. And then for my rise, I was taking my y1 and my y2, adding them together, and again, dividing by 2, all right? And then I just want to point out why we use brackets here. So we use brackets because it represents a coordinate. Right, we're determining what is the coordinate of the midpoint. So this formula is in brackets so that it's represented as an ordered pair with brackets around it. All right, so find the midpoint of the following line segments. So we'll do one together, and then we'll pause the video, and you guys can try the other one on your own. So we have 2 points. Without having to put this on a graph, let's just label our x1 values and our y1 values. So x1, y1, x2, y2. So we're going to use that midpoint formula. We're working on finding the midpoint of hi. So I'm going to use that hi as a subscript. So we would read this as the midpoint of hi. And then we're going to use that formula. So we're going to take our x values, which are 3 and negative 11, add them together, divide by 2. Remember, this formula is in a bracket. And then we'll have a comma, and then we're going to take the average of our y values, so negative 7 plus 7 divided by 2. So the midpoint of HI is going to equal, and then we'll just start simplifying. So 3 plus negative 11 is negative 8 divided by 2, and negative 7 plus 7 is 0 divided by 2. So those will simplify to negative 4 and 0. So we could then say, therefore, the midpoint of HI is negative 4, 0. Okay? See if you can pause the video and figure out the midpoint for the next example for line segment JK. So there's the midpoint for JK. Hopefully you were able to sub into the equation and get that same solution. All right, so we're going to take a look at using our midpoint to help us when we're given other pieces of information or maybe finding part of the midpoint. So it says a line segment has one endpoint at negative 2, 1, and the midpoint of negative 6, negative 3. Okay, so it says find the other point. So this question, they're saying there's two endpoints, but what we're giving you is we're giving you one of the endpoints and the midpoint. Can you find the other point? So I always find it helpful to, let's identify these points. Let's give them a name or a letter as a variable. So let's call this point A. All right, and this is going to represent our midpoint of A, B, let's say. So if we're trying to find the other point, let's say we're trying to find point B. Okay, so we will first start by writing down the information we have, and then hopefully we can kind of work backwards. So we know that A is negative 2, 1. Right now we don't have B. So B, we're going to call it, let's call that our x2 and our y2, because we don't know what that is. And then we'll say that the midpoint of AB is equal to negative 6, negative 3. All right, so we can substitute into that midpoint formula and then plug in what we have. So midpoint of AB is going to equal, just write that formula down, x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. All right, so the midpoint we have, right, we have the midpoint is negative 6, negative 3, and then we have part of the other side of this equation. So our x1 value is negative 2. We don't have our x2 value divided by 2. And then again, we have our y1 value is 1, but we don't have our y2 value. All right, so knowing this, we can kind of break this up into the pieces that go together. So what I mean by that is that we know this negative 6, right, is going to be what this part of my midpoint formula calculates out to. And we know that this negative 3 is going to be equal to this part of my midpoint formula. So I'm going to separate those two out and work to solve for the unknown variables there. So let's start with our x value. So we know, I'm just going to draw a line to separate our work. We know negative 6 is going to equal negative 2 plus x2 all over 2. And I'm going to use some algebra now to solve for x2. I'm going to bring the 2 over to the other side on my denominator by multiplying. So we'll have a negative 12 equals negative 2 plus x2. And then I'm going to add 2 to both sides. So we'll have a negative 10 equals x2. And then I'm just going to do it in another color. We know for my y side of things that negative 3 is going to equal 1 plus y2 over 2. So I'll bring that 2 over to the other side of my denominator again by multiplying. So we'll have a negative 6 equals 1 plus y2. And then I'm going to subtract 1 from both sides. So you'll have a negative 7 equals y2. Okay, so we've determined our x2 value and we've determined our y2 value. So that's going to represent my point B. So we can say, therefore, the other point is negative 10, negative 7. So hopefully you can see how you can be asked many different questions related to the midpoint formula, and we can use algebra to find whatever's unknown in the particular situation. We have another example here where we're basically working with two different line segments, trying to find an equation of a line and put it in standard form. Hopefully we can remember that standard form from a few units ago. So a line goes through point A to B to make line segment AB. A second line goes through the midpoint of AB, and then at point C, 0, 3. What is the equation of the second line? Express your answer in standard form. So I would always recommend that we draw just a rough sketch to see what we're dealing with, and then it might help us see what we're supposed to do a little more clearer. So let's kind of draw a rough sketch. It's not going to be to scale. It's not even going to look accurate. It's just to kind of place what's going on with these line segments. So a line goes through the point A at -1, 6. So -1, 6, I'm going to say is going to be somewhere around here. Okay, and we'll say that's point A. And point B is at 3 and 2. So let's say that's somewhere there. Okay, and I'm just going to get my ruler out, and we'll draw a straight line if we can. Okay, so there's point or line segment AB. It says a second line goes through the midpoint of AB and point C, which is at 0, 3. So let's say 0, 3 is somewhere here. Okay, it goes through the midpoint of AB, which I'm going to say is somewhere like that. We don't know what's happening there, right? But we do know that this second line, I'm going to draw it in a different color. This second line goes through the midpoint and it goes through point C. So this is the line we're working with. I'm going to label that as the midpoint of AB. It says, what is the equation of the second line? So this green line, what is the equation of the line? So we're first going to work to figure out what is that point, M, because once we have another point, maybe we can start working towards finding at least the slope of that green line. Okay, so I'm just going to label, so we remember C is at 0, 3. We need to figure out what is the coordinates of this midpoint here. So let's use points on the green line. Point C and the midpoint of AB. So we have to figure out what that midpoint is. So let's find the midpoint of AB. So the midpoint of AB, all right, it's going to be averaging those x values and y values from AB. So my x values from A and B are -1 plus 3 divided by 2. And then my y values are 6 plus 2 divided by 2. So the midpoint is going to be 2 over 2 and 8 over 2. So finally, that midpoint is going to be 1, 4. Okay, so we have some information now about this point. This midpoint here is 1, 4. So I'm just going to draw, right? We calculated what that midpoint is right there. So now we have 2 points. We have point C and we have point M. So now we can actually work to find our slope. So let's find the slope of C, which is at 0, 3, and my midpoint AB, which is 1, 4. Okay, so my slope is, remember, is a lowercase m, is going to be the change in my y values, so we'll say 4 minus 3, over the change in my x values, which is 1 minus 0. So my slope is going to be 1 over 1, or simply just 1. All right, so we have our slope. That's part of being able to write the equation of a line, but we also need our y-intercept. So let's find our y-intercept, or find B, and we will use our slope, which is m equals 1, and we're going to use a point on that line. Let's just use that point we already have, which was 0, 3. So if we plug into y equals mx plus b, okay, I know my y is 3, my slope is 1, and my x is 0, and we're trying to find b. Well, 1 times 0 is just 0, so 3 is going to be equal to my b value. Okay, so we can say our equation, in standard form at least, is going to be y equals 1x plus 3. Now I'm just going to go up here for our last step, because the equation or the problem is asking us to rearrange into standard form. So that's our last step. Let's rearrange into standard form. So we have y equals 1x plus 3. I'm simply going to move my y over here so that it keeps my x term positive. So we're going to subtract y. We're going to subtract y from both sides. So we're going to be left with 0 equals x minus y plus 3. Okay, and that answers the question that we were given here. So express your answer in standard form. So x minus y plus 3 equals 0. That is all for your note for today.